Okay, so starting a little bit backwards, I'd like to take care of the back half of this, everybody. I'd like to start with question 49 and 50, and then we're going to go through 46 and 48. Again, I'm going to work on this a little bit backwards. And then after we do 46 through 48, we're going to go along the lines of where we left off. I think we left off on question 9 or 10?
Yeah.
10. So let's take a look at 49 and 50 to start off with. We have 3 scores, critical reading. What happened? Huh? Yeah. We have critical reading, math, and writing, and we have a combined score, of course. The first thing is to assume that the scores are independent and to figure out mean and standard deviation of a combined score. This should be nice, actually. Critical reading, that's going to be 496. Sigma for reading is 114. Sigma or mu for math is 514. Gosh, these are really low scores. Sigma is 117. I think I actually looked these up too. These are the actual scores. 488.
What is W?
Writing.
Oh, this is this was like SAT?
Yeah.
Wow, this makes me happy because that.
Okay, so we're going to go ahead and we're going to combine these, okay? So the first thing is our mean. We need to know the mean of writing plus math plus reading. And that's going to be the mean of reading plus the mean of math plus the mean of writing. Means are nice because everything just adds together. What is this equal to? This is equal to 496 plus 514 plus 488. And if you add that together, you get a mean of whatever this says, 1498?
Yeah.
1498. So that's the average combined score. Doesn't that make you feel good about your score?
Yes.
Okay, now remember that you can't actually start by looking at the standard deviations. You actually have to go through the variance. So the variance of reading plus math plus writing, that's going to be the variance of reading plus the variance of writing plus the variance of math. This is supposed to be math. Okay, they didn't give you those numbers, but they gave you the standard deviations. Standard deviations are 114. Standard deviation of math is 117. Standard deviation of writing is also 114.
Why is writing? Because of the variance. Yeah, if it's you square the standard deviation, square the variance.
It doesn't work. Has to be variance. Always work with variance. Do not work with standard deviation. So I'm just going to add all these together. I would do it on my I better do this on my calculator. 114, 117, 114. 114, 117, 114. Okay, let's clear that out. 114 squared. Oh, wait, hold on. F6 and S. Darn it. F7 plus F. No. F6S? No. No, a square is just I. Plus 117 squared. Plus 114 squared. That gives us 39,681. 39,681. And that's going to be the variance of the combined scores.
What is it?
And then, of course, to find the standard deviation of the combined scores,
Square root it.
you just square root. So we're going to do the square root, which is second I of the answer. And that gives me that 199.2.
So it doesn't work if you just add a standard deviation?
Exactly. It does not work if you just add standard deviations. You have to add variances. Okay. If you're combining variables. Combine variances. Not. That's fun. I better keep that there. Not standard deviation. I didn't even know how that got there.
This is the final.
Sharona.
No, they're like arguing about it.
This is part of our final, but it is chapter 7.
This is chapter 7.
I'm looking at this like it's a different your final.
I don't know why Roya thinks this is so complicated.
Wait, I think this is what they're trying to figure out. Does the final have chapter 7?
Yes.
No.
Okay, moving on. 46 through 48. 46. Oh, 50. Sorry. 50, assuming that the scores follow a normal distribution. What's the probability that a combined score is greater than 2,000? So we want to know the probability that a combined score, let's say X is a combined score. Oh, you know, if we're going to do this, we should write down X, a combined score, is a normal distribution with that mean of 1498 and a standard deviation of 199.2. Remember, you really should be writing this
Wait.
on a free response setting. You would be writing this because you have to be able to tell the reader that you know this is a normal distribution. If you use normal curves and you do not state this is a normal distribution, you will lose points. So what's the problem that a randomly selected student has a score greater than 2,000? Okay. This is going to be the same as the probability that a z-score is greater than, and we're going to do the transformation again. That's 1498 minus 2,000 divided by 199.2.
Where'd you get 2,000 from? Because that's the number.
That's what they're asking, yeah. Hi.
I thought you can't do greater than.
Can't do what?
Greater than in a calculator for.
Oh, not for, you can do it for normal distribution, but you can't do it for binomial
You're
distribution.
doing binomial distribution.
This is not binomial.
This is normal? Yeah.
Hey, you know, you're really driving me crazy right now. Getting driven a little bit crazy right now, everyone. Okay. If you have something to discuss, then please take care of that now. I'll shut up and get out of your way. Funny how that works. Okay, let's figure out our z-score. We're doing 2,000
Wasn't it 149?
No, it's
minus the mean of 1498.
Isn't it 1499
Yeah.
times 2000?
It's observed minus the mean. Oh, okay, yeah. Then you did it wrong in the
you
notes.
did it wrong in the notes.
It's backward in the notes.
Yeah, you said 1498 minus 2000.
Whoops.
Yeah.
Gives me a z-score of 2.52. That's a good z-score, 2.52. So that's equal to the probability that z is greater than 2.52.
I have a question.
Let me finish the calculation, then we'll get there. Okay, and lastly, we're going to go ahead and figure out this. Let's see. That is F6 Shift V. I'm learning. That's learning. Z-score of 2.52 to positive infinity.
What did you say, 6? How do we know when we're supposed to keep it to -1e99?
1e99 is the far right side. Negative 1e99 is the far left side. So if you want the left tail, you're going from negative 1e99 to a z-score.
So it'll. So
If you want the right tail, you're going from a z-score to 1e99. We want a right tail.
Right now we want the right tail.
Right tail, yeah.
Okay.
Why can't we have a different?
Yeah, you know, why don't we just draw this then? That's 0059. Let me write that down first. 0059. Yeah, I really should have drawn this for you. So let's draw what we're looking at. We're looking at a normal distribution, which looks like a sombrero. Okay. The mean of my normal distribution is 1498. And it has a z-score of 0. And I want to know the probability that we're greater than 2,000. Okay. Greater than means, well, bigger than. So the bigger side is to the right, so I'm going to shade to the right of that line. This is the area I want. We just found out that the z-score was 2.52, so that's why I'm putting a 2.52 here. So basically the area that's greater than 2,000 is the same thing as the area that's greater than a z-score of 2.52. Okay. One more quick thing, sorry about that, is at the very end here, if you're having trouble knowing, I would put a 1e99 there and a negative 1e99 there. That would kind of tell you when you use which infinity. Okay.
I know you want us to do this one, it's like an FRQ, you want us to like write it out and stuff, but if it's a multiple choice, can we just plug in onto the calculator the 1498 and the 199.2?
I'm not going to teach how to do that, but you can.
Because I just did it the same way you did it with the Z.
Like I said, I'm not going to teach how to do it, but you can.
It will come out the same answer.
Okay. Any questions with 50? Okay, let's take a look at, we said we were going to go backwards, so we're going to go to 46, right?
Wait,
No,
That's all
48
the
or
answer.
47. Oh, it's all the same.
that was just it.
I think this one is a really difficult one, if I remember correctly. Let's take a look at 46 through 48.
Maybe whenever you use the Z score.
Whenever,
When you're supposed to use it, like the times.
normal distribution.
Always?
Z-score means normal distribution. Normal distribution means z-score. They're pretty synonymous. Andrea?
Oh, are we doing 46?
Yeah, we're doing 46 through 48.
Quick question. Okay, z-score, can you just say the equation? It's going to be x minus mean divided by x.
Yes.
Then you don't need to.
Okay. I'm going to write it anyways.
Okay.
This is one of those equations which you're not going to get by unless you memorize
Yeah, and
this.
x is gonna be whatever they say they want greater than or less than of it.
Yep.
Okay, that's why it's 2,000 minus
Yes.
1498.
Exactly.
But we found. Okay, I'm good.
Okay. Where are we looking then?
46.
46. A lottery game allows you to choose 6 numbers as integer from 1 through 49. You'll get 4 numbers correct, you win 20,000. You get 5 numbers correct, you win 40,000. You get all 6 numbers correct, you get $1,000. The game costs $1 to play. What's the probability of choosing exactly 4 numbers correctly? It's a fun one. Okay, so 4 numbers correctly exactly, 46. Actually, when you do this problem, you know everything that's going to happen. You know that the first number you pick is going to be correct, right? So what's the probability of getting that first number correct?
100.
There's 6 numbers, right? So it's 6 out of 49. 6 out of 49. That first number is correct. What about the second number? 5 out of 48. How many correct numbers do we need? 4. Okay. Next correct number? Next one correct? Okay. And this is where we kind of start to, we have to really think about this. If we're getting precisely 4 numbers correct, that means we're getting 3 numbers wrong. Okay? 2 numbers wrong. 2 numbers?
Yeah, there's 6.
6. Okay, so the next number has to be wrong. How many wrong numbers are there?
40.
There are 43, right? 43 wrong numbers out of 45. There's
What is it, 43 numbers? Why 40?
well, if we start when we started off, we had 49 numbers. 6 of them were correct.
Four.
4 of them?
Yeah, because we have 6 of them.
Oh my gosh.
No. There are 6 correct numbers and there are 43 incorrect numbers. You're choosing 6 out of the. You're choosing 4 numbers out of 6. You're getting 4. There are 6 numbers. There's 6 of the ping pong balls come up, right?
To choose from.
And you only need to get 4 of those ping pong balls correct.
To get it.
Okay. So we're just calculating what's the probability of getting exactly 4 ping pong balls correct. So the probability of getting that first ping pong ball correct were the 6 numbers on the ping pong balls
49 total.
out of the 49 total.
So then once that one ping pong ball, it goes down.
You have 48 and you're trying to get.
Okay. Now that we've got all 4 of the 4 ping pong balls correct, the remaining 2 have to be incorrect.
Would
Becau-
the next one be out of 44?
Yes, it would.
So
You may-
42
Why
out of
is it
44.
40? Why is it 43? Is it because 2 from the 45?
43, 6 out of the 49 what you started with are incorrect. So really this question is, what's the probability of getting 4 correct balls and 2 incorrect balls? Right? That's what we're really asking. Now, I don't know what this number is. I might as well calculate this. It's 6 times 5 times 4 times 3 times 43 times 42 divided by 49, 48, 47, 46, 45, 44. Okay, that's a really small number.
And that's the probability.
That's the probability. 0.00006,
Can we do 6.457, whatever e to the.
which is equal to 0.00006
4, 5.
4, 5.
Can we leave it to e to the negative 5?
I prefer if you didn't. And the reason why I'd like you to just write it out is I really want you to appreciate how small this number is. 47. Now we're supposed to figure out the probability of getting 5 balls correct.
So we,
Figured
okay.
it out.
No, we did 4.
Okay, 4 balls. All right, so to get 5 balls correct, 6, 5, 4, 3, 2, and then 1 ball incorrect. Yeah.
Would you get mad at me if I did like e to the whatever and I wrote that, but like what if I write that number wrong? Do you get what I mean?
Yeah. Would I get mad? I
Like,
don't
would
get
you,
mad.
Well, like, you know, would you mark it off? Would you mark it off, I mean?
Well, it would
I
be.
think you'd have to lose some points.
But not all the way.
Just
Why is it
practice
still
it.
43?
You,
It's 49 minus.
Nicole, practice it.
Because now we only have that one ping pong ball incorrect. And remember, we start off with 43 incorrect ping pong balls. Okay?
Well, the
All right.
43 is given to us as the number.
The 43 is
Okay.
No, 43 is not giving. They're giving to you that you have 49 ping pong balls.
Oh, and if 6 are correct, then
6 are
43
correct.
are wrong. Okay.
All right, let's calculate this probability.
Wait, right into us why 42.
Because you already have 6. You need 6 as well.
Yes. $49, $48, $47, $46.
Wait, what are you calculating?
If you get 5 correct.
Yeah, so this is 5 correct balls.
It is times 43. No, because we started with 43.
Wait, where did the 2 come from? We only have 42 left. Did you did.
Oh, now we're doing 5 correct balls. So correct, incorrect.
So we did 4 numbers. That's 49 in all. It's gonna be
Okay, so again, with this one, hello? So we got correct, incorrect. 5 correct balls, 1 incorrect ball.
I'm sorry, for the one you got when it was 4 correct and 2 wrong, wait, why did you multiply it by 2?
This isn't. This is for 5 this is for 5 correct. All right, so this is 5 zeros and then a 3, right?
How do you know to round to?
5 zeros, give me a second. 1, 2, 3, 4, 5 zeros and then a 3. How do I know what to round to?
Like how many numbers?
You kind of take a significant digit approach here. Okay. You want that 3 there because it's the most significant digit, but anything after that is pretty insignificant. Lastly, what's the probability of getting all 6 numbers correct? Okay.
On here, you said that it was 42 over 44. For the last one, is that
Hang on.
42 over 45?
The last one.
Instead of putting 43 over 44, you put 42 over 44.
for both of them.
Which one?
For the one that was 5 correct, on the answer, you put 42 over 44 instead of 42 over 44.
Yeah, that should be 43.
Thank you.
Okay, it doesn't change the answer appreciably, thankfully. Lastly, we're going to figure out what's the probability of getting all 6 of the ping pong balls correct. And it's a pretty small number. Yeah, that's going to be 7 zeros and a 7. 7 zeros and a 7. 4, 5, 6, 7 zeros and then a 7. Yeah, that's really small. Good luck.
This isn't
Gosh. Even 4 out of 49 is pretty small probability, right?
That's why you shouldn't bet on the lottery.
This isn't the lottery.
You said it was the lottery.
It's a lottery.
Game. Yeah.
Sharon.
Create a probability distribution for the game. Okay. Now this is a bit of a cruel question. I'm gonna fully agree. This one is pretty cruel.
So can you?
So 47. You gotta let me finish talking. Gotta let me finish talking. We gotta figure out what's the probability of getting 0 of the ping pong balls correct. Okay, that means that we're all coming up wrong, right? 43, 44, 42, 41. Is that 6 yet? No.
Wait,
Wait, why is
it's
there
not
44?
44 is mine.
Isn't it?
Gosh. Ay, ay, ay.
Why are we doing probabilities?
So if we're going to create a probability distribution, we're going to have to get all of the probabilities from 1 through 7. Now we did 4 through 7. We just need to get 0 through 3. So that's 1, 2, 3, 4, 5, 6. 6 out of... Ay.
No, it's out of 49.
So is this a chance of it happening?
This is a chance of it not happening.
There's a chance of getting 0 of the balls correct, right?
Out of 49.
Out of 49, yeah. So 49, 48, 47, 46, 45, 44. Note that the denominator stays the same. Okay, let's get back to the calculator and do this. Okay, 43, 42, 41, 40, 39, 38. I think that's all of it, right?
Yeah.
Great. Probability of getting no correct answers is 43. Hello? Hello? Okay, I'm going to send someone down there right now. Are you sure? With a pen, sure, no problem. Will do. Bye. See you in a minute. Okay, who's gonna be our pizza person?
I went every single time. You guys
You need to sign for me, okay?
Share bear.
Look at that.
Do I get a kiss, Sharon?
The probability of getting none of the ping pong balls correct is 43%. That's awesome. Probability of getting 1 ping pong ball correct.
Now we have to do 1. Oh.
We're supposed to do all 6.
Wait, okay. You figured that out because it's like a probability distribution.
Probability of
For the
one.
one.
So it'd be 1 out of 49. No, right? Or 6 out of 49.
That's equal to...
Yeah, 6 times 43 times 6.
6 times.
Oy, what did we do?
49 times 43 out of 48.
It'd be 1 out of 40.
Yeah, 6 times 43 times 42 times 41 times 39 out of...
Wait, what happened before? 40.
Question? if I put the 6 at the end and I started with 43 out of 49, 42, 48, so at the end I would do 6 out of 44, would that be the same?
That's fine. 9, 48, 47, 46, 45, 44. Okay, so this, I know how tedious this is. This is going to be the last one of these we're going to calculate. I think you should be able to do this now, right?
Yeah.
But what I don't understand is.
Let me, wait. Alright, I'm going to just go ahead and do this. Change this to a 6. We get a probability of, oh, look how dramatically that dropped. Six, 8, 8, right?
So whenever it asks for a probability of something, we always start with the numbers that it's given, like because it's given like 6 out of 49. So then you just make the ones that are correct exactly for two that are incorrect.
Yeah.
So, can you explain, so the 43 has that because we have 6 correct ones, right? But how do you know that 6 is correct?
How do we know that what?
We have 6 correct.
Because it says.
Where?
It's rolling.
Okay, moving to 48, and then we're going to take a break.
Doing on Monday.
What is the, oh no, what is the expected winnings of the game?
On one game. Oh, wait.
Okay, so really we're supposed to figure out all of these, so let's just do this real quick. I'm going to do the probability of 2 correct answers.
Just one more.
So I'm going to really have to do this quickly. So the probability of 2 correct answers is going to be,
6 times 5.
now instead of that 39, I'm going to get a 5, right?
Can you just replace that?
So 0088. Probability of 3 correct answers. Change that 40 to a 4, right? Three zeros and an 8.
What is this for?
3.
We need these numbers to figure out the answer.
Didn't we do 4 though, and 5 and 6?
3 zeros and an 8, 8.
42 times 1. 5 times 3.
Right?
Bro, P2.
6 times 5 times 43 times 43 times 41 times 40.
Why is it not real?
Okay, and we already did 4, 5, 6?
Yeah.
Great. What was the probability of 4?
Oh, 3 is 3 zeros in it?
Probability of 4 was
0.00000645.
so 4 zeros
And then 6 right back.
and then probability of
We already got
5 zeros and 3.
0.000003.
So 5 zeros. And probability of 6 was 7 zeros
Yeah.
and a 7.
I don't like this.
I don't like that.
Something's weird here. These probabilities should add up to 100%.
Do they?
Why
Maybe
don't,
this should just not.
I'm wondering why they don't add up to 100.
What is it? What does it add up to?
It looks like they add up to about 51. No.
51%?
Yeah, it looks like,
Did we make a mistake?
it's a great question.
Oh, did you add the probability of 0?
Because the probability of 1.
Did you add the 43%?
Oh my gosh.
What?
This is
Sharon.
this is binomial.
Sharon.
Gosh.
No, it's not binomial.
Sharon.
Sorry. We're gonna just. I'm gonna kill this question next year. By the way.
Can we kill it? Kill it now.
Yeah, we're gonna kill it now.
Wait, so 47?
48 was good.
Yeah, 46 through 48. Just kill those questions.
I'm gonna erase it.
I actually understand. I didn't understand it at all. We're doing it wrong. I know. I understand the wrong stuff. I don't understand the right stuff.
Pizza time.
Okay.
Do you want me to erase it?
I'm gonna